complementary angles. Complementary angles are two angles that add up to be 90 degrees. They make a right angle or a corner, right? Corner. Okay? That's how I remember complementary angles. C for corner. Okay? Alright? Actually, CO if you're being technical for corner. Okay? Alright? So, my question to you is this. If I say that my angle is theta, that was a good one. Okay? If I say that my angle is theta, how can I represent numerically my complement to theta? The complement then would be 90 minus theta. Yes? Agree with that? Because then they both add up to be 90 degrees. Okay? What if we were in radians? Then what's my complement? Dylan?
It would be pi over 2 minus theta.
You agree? Yes. Everybody agree? Pi over 2 minus theta. Okay? Now, let's explore a little bit about complementary angles. So, it doesn't matter what kind of a calculator you use for this. You can use a regular old scientific one. If you want to use a graphing one, that's fine. If you want to turn your phone to the side and use your phone, because that works too, okay? What I would like you to do now is I would like you to compare the sine of 20 degrees to the cosine of 70 degrees, because 20 and 70 are complementary angles. Okay? Sine of 42 degrees to the sine of 48 degrees. To the cosine of 48 degrees. The sine of 68 degrees to the cosine of 22 degrees. What did we find? They're the same. Okay? So, those two are the same thing. Those two are the same thing. And those two are the same thing. Is that going to happen with every single complementary angle? Where the sine of the angle is going to be equal to the cosine of the complement. Okay? It will, actually. Because if you think about it, in terms of a right triangle, if I say that this is angle A, then that would be side A. If this is angle B, then that's going to be side B. If that's angle C, then that's going to be side C. Right? If I think about that, the sine of angle A is equal to what? On that right triangle? A over C. And the cosine of angle A is equal to B over C, right? Well, now if I flippity-flop that, and I go the cosine of angle B, that's going to be side A over side C. Because the side angle A's opposite side is angle B's adjacent side. And the sine of angle B is going to be B over C. Okay? So that will always happen. The reason that we did that little exploration is because of properties numbers 12 through 17. Okay? The complementary properties. So the sine of an angle's complement is the cosine of the angle. The tangent of the complement is the cotangent of the angle. The secant of the complement is the cosecant of the angle. Cosine complement is sine. Cosecant is secant of the complement. Cotangent of the complement is tangent. Okay? Flip, floppity, floppity, flip. Okay? So we can use those now to simplify something that looks like that. So, if I were looking at this particular one, yes, ma'am?
So is U interchangeable with X and theta?
Yes.
Okay.
Yes. First off, I would change sine of negative x to what? Negative sine of x. I would change secant of pi over 2 minus x to what? Cosecant of x. What would you do next?
Make cosecant into, break it down
Into what?
into 1 over sine of X.
So that becomes what? Just what? Negative 1. Okay? Try that one. I get just sine of theta. Agree? Questions? Okay. Try that one. So I would first do cosine of x times cosine of x over sine of x. So that becomes cosine squared of x over sine of x. cosecant is 1 over sine of x. Luckily, they're already in common denominators, so this becomes 1 minus cosine squared of x over sine of x. 1 minus cosine squared becomes sine squared so this ends up just being sine of x. Okay? Questions on that one? What am I going to do in this one? Distribute. I can multiply the top, right? Okay. So the top becomes 1 minus cosine of x, right? Plus cosine of x. What is that? Minus cosine of x plus cosine of x goes away, right? Okay. Minus cosine squared. One minus cosine squared of x is sine squared x. Sine squared divided by sine is good. Try, oops, I gotta unmask it first. Unshade it. There you go, try that one. Alright, so this would become, on top, I would get secant squared of y minus tangent squared of y all over secant of y. Now, have you ever been watching one of those cheesy TV shows or cheesy movies when they're trying to defuse a bomb and they cut the wrong wire and the clock starts going faster? You know what I mean? You know what I'm talking about? That's what would happen if you canceled out your secants. You cut the wrong wire. Okay? So now you got to think fast to fix it. Okay? Because your time's running faster. Okay? Why can't I cancel out those secants? Let Daniel talk.
The top, there's 2 terms.
There, and more importantly, there's a minus sign up there. Yep, a plus or a minus sign, an addition or subtraction sign. Okay? So I can't do that. So I got to go a different way. Okay? So what way do you want to go? Is for secant squared. So secant squared, according to formula number 11, the top says, or the on top, secant squared is the same as tangent squared plus 1. Okay? That's one way. What if I don't like, what if I like secant squared? What's tangent squared? Use number 11.
Secant squared minus 1.
Tangent squared is secant squared minus 1. Okay? What if I don't like either one of them and I want to get rid of them both at the same time? What's secant squared minus tangent squared? It's 1, right? All based off of formula number 11. Okay? So this would be tangent squared of y plus 1 minus tangent squared of y all over secant of y. Already don't like that. Went too fast. So what's my top? 1. One over secant is cosine. Like by you switched them, you went secant squared is 1 over cosine squared.
No, I like did secant y minus tan.
You did what now?
Or when you said you can't cut the string,
Yeah.
I did it, but I still got cosine y.
You got lucky. Because it shouldn't work. Because it's bad math. You know what I mean?
Yeah.
It's math that doesn't make sense.
Could you do that if it was multiplication? on
If it
top?
was multiplication on top, yes, by all means you can do that.
Even if tan didn't have secant
Mm-hmm.
directly attached to it? Well, it technically does.
It would if it's multiplication. Yep. Yep. Okay? Now, little side note action for you. What if I was just the meanest teacher ever and I gave you 3x plus 2 equals x? And I said solve. What would you do?
X is to one side.
Okay, so how would you do that?
I would subtract 3x.
Okay.
And then divide that both sides by negative 3.
Yeah? What if I don't like doing that? What's my other option? I could subtract x from both sides and then subtract 2 from both sides, right? You can get positive 2x equals negative 2 and then still get negative 1. Okay? What if I was just the meanest teacher ever and I said 7x equals x squared plus 12?
Bring the 7 over.
Okay. The 7 or just the 7 or 7x? Okay. So you would subtract 7x. And then that becomes 0 equals x squared minus 7x plus 12.
You can see if you can do that factor thing.
Okay. If I can double parenthesis it. Okay. Is it double parenthesable?
Yeah, it's more frequent. Yeah.
What if it's not?
Then there's that other.
Quadratic formula. Okay? Alright? Am I done?
No.
No, because now I gotta do what?
Set both parentheses equal to 0.
I gotta set each one of these equal to 0 and solve those. So I get x equals 3 and x equals 4. Right? What if I was just the meanest teacher ever and I said 2x squared equals 8? Divide by 2 on both sides. Then what? Square root, what's my answer? No.
Minus 2.
Okay. Yeah? Can you handle that? That's the next 2 days in pre-calc. Okay? Except instead of x, it's going to be a trig function. It's going to be like cotangent of x. Okay? But what, Nina? It is the same. It is the same. Okay? So, for instance, let's look at this function. We're going to solve this on our unit circle, so we'll need our unit circle. We're going to solve it over the interval 0 inclusive to 2 pi exclusive, which means 1 full lap around the circle. Okay? So, what would you do first if it was 3x minus 2 equals x? So I would subtract what? Subtract 3 cosine of x. What do you get then? Is equal to negative 2 cosine of x. Now what? Divide by negative 2. So we get where on the first lap of the unit circle is cosine equal to 1. Yeah? Can I use 2 pi though? No, I can't use 2 pi because it says that 2 pi up here is exclusive. Okay? But I can use 0. So x here has to equal 0. No, I don't know what you mean. Well, if it was sine, yeah. Yeah, I see what you're saying. If it's sine, yes. If it's tangent, yes. You know what I mean? If it's secant. So on your unit circle, what's the tangent at pi over 3? Square root of 3. Okay? All right. Let's try another one. 3 cosine of x plus 2 equals cosine of x plus 1. I would subtract cosine and 2 at the same time. So that gives me 2 cosine of x equals negative 1. So that gives me cosine of x here is negative 1/2. Where on my unit circle is cosine equal to negative 1/2? Yeah? Yes.
I have 2 pi over 3, and then also 4 pi.
Now, thinking type question. I know last week was thinking week. This week is logic week. The week before that was inverse week. Okay? In inverse week, we limited cosine to the top half of the unit circle. In solving logic week, which we're in right now, do I have to limit to the top half? No. Okay. That's just with inverse functions that you have to limit to the top half. Okay? If you're solving, it's on the full lap of the unit circle. Not including 2 pi. So only use 0 or, so only use 0, but means the same. Okay? Just when you think you have all the answers, I go and I change the question. Try that one. What would you do first? I'd subtract 1 also. Gives me the square root of 2 times the sine of x equals negative 1. Then what would you do? Good. Divide by the square root of 2? Yep. I would divide both sides by the square root of 2. That gives me the sine of x equals negative 1 over the square root of 2. Do I like negative 1 over the square root of 2? No. I would rationalize that. So that gives me the sine of x equals negative square root of 2 over 2. Where on the unit circle is the sine of x equal to negative root 2 over 2?
Can you explain why you can't square both sides? Because
Okay.
they cancel and just become 2 sides.
So if I square both sides from this step, right?
Yep.
It would become 2 times sine squared of x equals positive 1. Agree. Divide both sides by 2. Gives me sine squared of x equals 1/2. Agree. Square root both sides. Sine of x equals plus or minus the square root of 2 over 2. Agree. That gives me x equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4.
So you get them, but they're just too many.
Because if you look back into this problem, if I dive deep into this problem, this right here has to be negative. Because I've got a positive number times something plus something, or plus 1, equaling 0. So that yellow box has to be negative. So these two then would have to get kicked out because those give me a positive sign value.
Like, let's say you do that, and how do you make it, and you do it that way?
Mm-hmm. But if you don't do it, if you don't kick out those two, you're wrong. Okay? Alright? Good questions. Any other questions on today? Yes, ma'am.
Could you just square the square root of 2 and not the sine?
No.
Because root that term, like,
Okay? That's all I got for you today.